Assalamu alaikum, my dear students. How are you? Hope you are fine by the grace of Almighty Allah. Welcome to NIEVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today, I am going to take a physics class for class 9 students. My dear students, our today's topic, Chapter 3, Reading Done, Part 1. Our today's lecture number 15, SW number 13. My dear students, let's start our class. Today we will start chapter 3, force. Okay, in our previous class we have learned about velocity, speed, acceleration, deceleration, distance and their mutual relationship. And in this chapter we will learn about the force, how force are created, force can be created, motion can be created, or motion can be influenced by applying force. We may begin with Newton's first law. Okay, at first we will discuss Newton's laws of motion. Newton's first law of motion: a stationary object will remain stationary and an object in uniform motion will continue its uniform motion unless a force is applied to it. My dear students, I am repeating. Newton's first law of motion: a stationary object will remain stationary and an object in uniform motion will continue its uniform motion unless a force is applied to it. Since velocity is a vector quantity, for uniform motion the object will not change its direction of motion, it will move along a straight line at uniform speed. Now, Newton's second law: the rate of change of momentum of a body is proportional to the applied force acting on it, and the change of momentum also takes place in the direction in which the force acts. Now, Newton's third law: when an object applies a force on another object, then that object also applies a force of equal magnitude on the first object but in the opposite direction. My dear students, this is the Newton's laws of motion: first law, second law and third law, and you have to memorize these Newton's laws of motion. Now come to inertia. Inertia, the characteristics that a stationary body wants to be stationary or a body in motion wants to keep its motion unless a force is applied to it, called inertia. My dear students, inertia is the another form of Newton's first law. Okay, the characteristics that a stationary body wants to be stationary or a body in motion wants to keep its motion unless a force is applied is called inertia. And inertia is of two forms: inertia of rest and inertia of motion. At first, inertia of rest: an object at rest tends to stay at rest. This tendency is called inertia of rest. For example, my dear students, see this example. When a car at rest suddenly starts moving, we move backward. The lower part of the body is attached to the car. When the car starts moving, the lower part of the body moves with the car, but the upper part of the body is still stationary and tends to remain stationary. So the upper part of the body moves backward. And since this inertia is due to the tendency of rest, this is called inertia of rest. My dear students, this is the best example of the inertia of rest. And now come to inertia of motion. An object in motion tends to continue its motion. This tendency is called inertia of motion. Here is an example. When we try to get down from a moving train, we fall in the forward direction because of inertia of motion. The whole body of us remains in motion. When we try to get down from the moving train, the lower part of our body comes to rest. The upper part of the body keeps moving forward due to the inertia of motion. That's why when we try to get down from a moving train, we fall in the forward direction. My dear students, in the exam, question may arise why we when we try to get down from a moving train or car, why we fall down the forward direction. Okay, this is the answer. Now come to nature of fundamental force. Fundamental force are the four primary forces in nature, and all other types of force can be derived from them. Okay, these are gravitational force, magnetic force, weak nuclear force, and strong nuclear force. My dear students, now we will discuss about gravitational force, electromagnetic force, weak nuclear force, and strong nuclear force. Okay, gravitational force. All objects in the universe attract one another by a force due to their mass. This force is called the gravitational force, and the force which acts without any contact of two objects is called remote force. In the case of the gravitational force, there is no direct contact between the objects. For example, gravitational force exists between the sun and the earth, though they are separated by 1.5 million kilometers, as there is no direct connection of the case of in the case of gravitational force. This is a remote force. My dear students, in the exam question will become why gravitational force is called a remote force. Then you have to say what is remote force. Okay, remote force means the force which acts without any contact of two objects is called remote force. Okay, and in the case of gravitational force, there is no direct contact between the two objects. That's why gravitational force is a remote force. Okay, now electromagnetic force. The attractive or repulsive force between charged particles is called electromagnetic force. My dear students, I am repeating what is electromagnetic force. The attractive or repulsive force between the charged particles is called electromagnetic force. It is much stronger than the gravitational force. That means 10 to the power 36 times. My dear students, this is the another characteristics of electromagnetic force. Okay, electromagnetic force is much stronger. That means 10 to the power 36 times stronger than gravitational force. Okay, for example, when we comb our hair with a comb, it attracts pieces of papers. We have also seen that a magnet attracts or repels another magnet. We know electric and magnetic forces are different in nature. Actually, the two forces are identical. My dear students, you may practice done this experiment at your home. When we comb our hair with a comb, it attracts a piece of papers. Okay, this is the example of electromagnetic force. Now come to weak nuclear force. It is called weak because it is weaker than the electromagnetic force, but it is much stronger than the gravitational force. Okay, the force of gravitational and the electromagnetic force can act from any distance, but this force acts for very small distance. That means 10 to the power minus 18 meter. Okay, the emission of beta rays or electrons from a radioactive nucleus is due to this weak nuclear force. Now, strong nuclear force. This is the strongest force in the universe. This is 100 times stronger than the electromagnetic force. But these two acts at a very small distance. That means 10 to the power minus 15 meter. My dear students, this is the another characteristics of strong nuclear force. Strong nuclear force is 100 times stronger than the electromagnetic force. That means at first strong nuclear force, then electromagnetic force, then weak nuclear force, then gravitational force. Okay, now we know nucleus is situated at the center of the atom, and the strong force acting between the protons and the neutrons within the nucleus confines them. Confined due to this strong nuclear force, the nucleus contains an enormous amount of energy. My dear students, therefore, by the division of a large number of nucleus or the addition of a small nucleus, a huge amount of energy can be produced. And for this reason, nuclear bomb has so much energy, and by this force, light and heat is produced in the sun. Okay, now come to force. What is force? My dear students, the definition of force of your textbook is not clear. That's why you have to memorize this definition of force. Okay, force is thing that when we applied on a body at rest changes or tries to change the state of rest to motion, or when applied on a body in motion changes or tries to change its state of motion to rest of changes the shape and size. This is called force. My dear students, I am repeating. Force is thing that when applies on a body at rest changes or tries to change the state of rest to motion, and when applied on a body in motion changes or tries to change its states of motion to rest and of changes the shape and size of that. Okay, force is indicated by F, and we know F equals to ma. M means mass, and A is acceleration. So the unit of mass is kg, and the unit of acceleration is meter per second square. So kg meter per second square is called Newton. So the unit of force is Newton, and the dimension of force is the dimension of mass is m, and the dimension of acceleration is L per t square. That means ml per t square is the dimension of force. My dear students, now types of force. There are two kinds of force, balanced force and unbalanced force. Now what is balanced force? If the resultant of applied forces is equal to 0, then it is called balanced force. My dear students, I am repeating. If the resultant of applied force is equal to 0, then it is called balanced force. Now see this figure. This is the example of balanced force. Here here is a box. Okay, we will apply applied force in this side, in this direction, 25 Newton force, and we also apply in this direction applied force 25 Newton. Now we have to find out the resultant. Okay, to find out the resultant, 25 Newton subtract, we have to subtract these two forces. Okay, that means 25 newtons minus 25 newtons, that is 0 Newton. Okay, my dear students, this is that means this is 0 Newton. That means the resultant of applied force is equal to 0. So this is the example of balanced force. Okay, my dear students, see here the here two forces is acting on the opposite direction, and cancelling their actions and producing a balanced condition. So this is the balanced force. Now unbalanced force. What is unbalanced force? If the resultant of applied forces is greater than 0, then it is called unbalanced force. I am repeating, if the resultant of applied forces is greater than 0, then it is called unbalanced force. Now see this example. Here is a box, and we will apply force in this direction 150 Newton, and we will also apply force in this direction 25 Newton. That means this we will apply this force is acting is in opposite direction, and we have to find out the resultant. So 150 Newton minus 25 Newton, that means 125 Newton. So in the definition we say, if the resultant of applied force is greater than 0, then it is unbalanced force. So here 125 Newton. So the resultant is greater than 0. That means 125 is greater than 0. So this is unbalanced force. My dear students, hope you have understood our today's topic, and our today's SW number is 13, and your SW topic is Newton's laws of motion. Newton's laws of motion, and submit on Saturday. My dear students, your today's SW topic is Newton's laws of motion. That means first law, second law, and third law. My dear students, memorize this our today's topic properly and keep practicing at home with writing. and do SW regularly and submit SW regularly. See you again in the next class. Allah Hafiz.